All right. So today we're going to be mainly working on metric conversions and dimensional analysis using metric conversions. That and the density problems that you've been working on the last couple of days, you'll see that on the quiz, like I said, on Monday, and then the test. I had downloaded in Google Classroom 2 nights ago a video that was over density, and then that you should have watched. I sent it out on Sports U and assigned it. And then last night I downloaded one that was not one of my lectures over metric conversions and dimensional analysis, and sent it out on Sports U. So hopefully you watched those. If you haven't, you'll want to go back and watch those. Part of the notes you would have filled in from theirs. All right, Humberto, show me what you got. So we decided it's going to be 2 sig figs because of my 11, right? We're always going to do the smallest. So what's my formula? Just, if you'll start by writing your formula. Okay. Density equals mass divided by volume. All right. So in this, you sig figs, you got something longer on your calculator, but you had to adjust out. If you left it just like that, I wouldn't give you credit, because what are we missing? All right, that's it, grams per mil. And then I keep forgetting the second part. Is it a intensive or extensive property? It is an intensive property, that's correct. All right, let's get on our notes. Let's see if I can get this. All right. When density is given to use as it's an intensive property, it's considered kind of like a constant. There's pages and pages of recorded density values for different compounds, for different elements mainly. So that means it's not part of your sig figs whenever you decide how many sig figs, even though it's written as 13.6. It's really 13.60000 continuing on. So it's not part of what your sig figs are. Your sig figs are going to come from your measurement. So my measurement in this case that I started with was my 76.2 grams. Elizabeth, would you like a paper copy of these? 76.2 grams. So that's where I'm going to get the fact that my answer needs to have 3 sig figs. So we said our density is equal to my mass divided by my volume. My mass I have and my density. So my density is 13.6 grams per cc is equal to my mass, which is 76.2 grams divided by my volume. Or you can rearrange your formula instead of doing this little bit of algebra and plug it in, whichever way works for you. But I'm going to do it this way. So I'm going to bring my V up. So I would have 13.6 grams per cc times V is going to be equal to 76.2 grams. So at this point, what am I going to do? Divide by my 13.6, right? Cancels out over here. And on this side, I get 76.2 divided by 13.6 grams per cc. So that's what I put in my calculator. Whenever I did that, I got something like 5.60929, maybe even a little bit more, but we said we only could have 3 sig figs, so that would be right here where my 0 is. Since there's a 9 behind it, it would become 5.61. My grams would have canceled, and I would have been left with cc's, which is the correct unit for volume. So just kind of the big takeaway in there is if you're given density, then that's not going to be part of your sig fig decision because it's considered a constant. All right, so what we're going to be spending most of our time on are conversions, specifically mainly metric conversions. So if you watch the video, he did these as kind of like a little stair, like a little ladder, works the same here. In the middle, I have my base unit. So those are my units without prefixes. And my number for that is 10 to the 0, which is the same thing as 1. On this side, these are larger than a unit. So in other words, on this side, it takes many units to equal one of these larger prefixes. So if I was talking about kilometer, that means it takes 1,000 meters to equal 1 kilometer. On this one, it's the opposite. These are smaller than the unit. So it's going to take many of these with the prefix on this side to equal 1 unit. So if I was talking about centimeters, it would take 100 centimeters to equal 1 meter. If I move this way, when I'm doing my conversion, my number should be decreasing. No, increasing. I keep saying that today. My number should be increasing. If I move this way, my number. Doing this, if you think that I make a mistake, please ask me because there's a good chance I'm making a mistake today. All right. So we're going to give all of these. You will need to memorize the order, or you would need to memorize the numbers with these coefficients. 1 tera unit is equal to 10 to the 12th units. 1 giga unit, 10 to the 9th units. 1 mega unit, 10 to the 6th. Kilo, 10 to the 3rd. Hecto, 1 hecto, 10 to the 2nd units. 1 deca, 10 to the 1, or just 10 units. So if I was talking about decagrams, it would take 10 grams to equal 1 decagram. On this side, because they're smaller than the unit, than the base unit, my exponents are going to be negative. So 1 deciliter is 10 to the minus 1, not deciliter, deciunit, 10 to the minus 1 units. 1 centi, 10 to the minus 2. 1 milli, 10 to the minus 3. 1 micro, 10 to the minus 6. 1 nano is 10 to the minus 9. All right. If you notice, I'm going to put a line right here. If it falls between, if both units, the unit that you have and the unit you're converting to, falls between those two lines, you can just move the decimal. But if anything is out of those two lines, that doesn't work. You can't simply say, okay, 1, 2, 3. And the reason is, if you notice, whenever I get outside of those lines, when my prefix changes, it's by more than 1 decimal place. In other words, this is 10 to the third. This is 10 to the negative third, 10 to the negative 6. That's more than just a 1 decimal jump. So for those, you're going to have to do a little bit more work. If they fall within these boundaries, then you can kind of just count how many, and then you can move your decimal. If you like a mnemonic to memorize those, he gave you one for the little shortened version, and I kind of just added on to that. So the great man, King Henry, died. And that gets me to the deca. And then I'm going to put a box just to remind myself that that's where my units without any prefixes go. Drinking chocolate milk many nights. Notice when we're using these different prefixes, the 1, because we're going to be using them as conversion factors. So 1 is always going to go with the prefix portion of the conversion factor. The number with the exponent is going to go just with the unit, the base unit that does not have a prefix. All right, so let's start off by looking at a few of these. So my first one that I have is, that's a big G, so that's gigameter. So that is right here. And I'm converting it to kilometers, which is right here. Gigameters is outside of that green line, so I can't just count how many decimal places because I'm going from 10 to the 9th to 10 to the 3rd. That's not just 1, 2 jumps. So what you do is you take the exponent of what you're starting with. In this case, it's a 9. And you take and you subtract the exponent of what you want to get to. In this case, it's a 3. So 9 minus 3 gives me 6. That tells me I'm going to move my decimal 6 places. Should my number be getting larger or smaller? Larger. So I'm going to move it the way that I'm making my transition. I would say 1, 2, 3, 4, 5, 6. So I would have 7,500 kilometers. Notice that your sig figs don't change. I have 2 sig figs here, and my answer should have 2 sig figs. If I would have put the decimal at the end of that, then that would have been incorrect. You want to maintain your sig figs. Also, remember metric system. When you're working in the metric system, you should just be moving decimals. Your number should not change. So at no time should I go to 0.0075 and end up with 860. My number is in the 75 shouldn't change, just where the decimal is at. All right, let's look at another one of those. All right, so I have 244,475.3 microseconds, which are over here. And I'm converting it to hectoseconds, which are over here. Hecto's inside that boundary, but micro falls outside of that boundary. So I can't just count how many places. So same thing, micro, I'm going to see what my exponent is with micro. It's a -6. And I'm going to subtract my hecto, which is a 2. So that gives me -8. So I'm going to move mine -8 places. So my number should be getting smaller or larger? Smaller. 1, 2, 3, 4, 5, 6. And then you'd have to give yourself a couple of zeros. So you would end up with 0.0024475. Same number as sig figs. All right, why don't y'all try the next one? So how many places are we moving our decimal?
12.
But no, it's a little tricky here because I'm subtracting a negative exponent. So that would make it positive. So it really becomes -6 plus 3. Okay. That isn't right. -6 minus a -3. Those two minuses together would come positive. So I need to move it 3 places. Am I going to make my number smaller or larger? Smaller, right? Because I'm going over here from here to make us just a little bit up, or milli right here. So I'm going to move it 3 places. So 1, 2, 3. So I would end up with 0.0000002. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that would be milligrams. Because my math on those was my first one was a -6, and I was subtracting from that a -3. So a negative, that would become positive. So that was like -6 plus 3. So that's where I got my -3 from. The -6 came from here, and we were going to milli little m, and there's my -3. Anybody have any questions on that particular one? All right, let's look at my next one. I think it's an easy one. If I look at my next one, I'm going from seconds, which are in here, to kiloseconds, which are here. So both of those are in the line. So I don't have to do all that. I can just see how many places I move. So I'm going to move 1, 2, 3. So I would move my decimal in the same place, 1, 2, 3, and I would get 2.10355. So if you come across one where both of the things where you're starting with, the units that you're starting with and the units you're trying to go to, if they're both within these lines, then you can just count how many places you're going to move and move the way that you count. If not, you're going to either have to do this little process or a little process called dimensional analysis, which is what we're going to look at now. So this might be where you need some extra paper, because I know that there's not enough room on your notes. So the paper that you picked up today is practice over what we're doing. And like I said, that quiz along with some density problems will be on the quiz on Monday. And we'll do a gizmo over this tomorrow. All right, so we're going to use a process called dimensional analysis, or I like to just DA, and we use it the whole year through. And it's when you use a system of conversion factors. To make the change from one unit to another. So we know that there are 12 inches in 1 foot. Probably most of us know that better than how many hectometer, how many meters are in a hectometer. And this is considered a conversion factor because it's equal to 1. It's equal to 1, just like 8/8 is equal to 1. It looks different because they're in different units, so the numbers aren't the same. But the fact that they are in different units, that's what makes them equal to 1. And that's the conversion factor. When you have some number with the unit over another number with the unit and they're equal to 1. So all of these different numbers that we've been talking about when we've been doing the metric system, like saying that we have 10 to the third meters in 1 kilometer. Or 10 to the -2 meters in 1 centimeter. Those are all conversion factors. Because these values, this and this, those values, when I put them over each other, equal to 1. It doesn't matter whether I write it this way or flip them the other way. The rule still applies. And we use this process and conversion factors throughout the whole year of chemistry. So we're going to look at a couple of metric conversions using it that way. And then you can kind of decide what you like better. All right, so I'm going to do the next one on your practice, which is 0.00091 tetraliters. That's a big T. And we want to find out how many megaliters that is. All right, so when you're doing dimensional analysis, you always start with your given, and that's also where your sig figs come from. So 0.00091 tetraliters, and I'm always going to put it over 1. So there's my given. And then somewhere down here at the top of the equals, put what you want to convert to, which is megaliters. I divided up in boxes. His might have looked a little bit different. I think maybe he did them with multiplication signs here instead of the dividers. It's the same process. So what's important here is your units, because you need your units to cancel out. Whatever unit I have up here, I have to have the same unit down and diagonal because I need it to cancel out. Now I want to get from tetraliters and I want to convert that to milliliters. Looking on your little number line with all your prefixes, do we know how many? Is there anywhere on there that tells me that relationship? How many megaliters are in a tetraliter?
6. Or is it because they're outside?
They are outside, yes, but it doesn't tell me directly, right? So what do they have in common? What does tetraliter and megaliter have in common? Liter. So let's convert to liter first. So if I look here on my little sheet, 1 tetraliter is equal to 10 to the 12th liters. We got that from what we marked at the very beginning in class. The 1 is always going to go with the prefix. The number with the exponent is going to go always with just the unit by itself. And now I continue following. If I'm liter here, I have to be liter down here. Kind of didn't need that much space, but that's okay. And we know this conversion. We know that 1 megaliter is equal to 10 to the 6 liters. That's the big M, not the little m. That can get confusing. That's what I did first or second period. I double check that my units cancel, which they do. I'm left with just megaliters, which is what I wanted. And now to finish it, you multiply across. And then you divide. Top by your bottom. Now on those yellow calculators, if you have a number with an exponent on the bottom, you're going to need to put it in parentheses. If not, it takes it out of order or it does them out of order or something. So try this in your calculator. So you're going to put 0.0091 times 10 to the 12th. You don't need to multiply it by 1. And I would get an answer. Where's your calculator at, ma'am? Okay. And then come back and divide it by 10 to the 6. And I would put that in parentheses. This right here, because all this one, these are just one. So this is the only thing I really need on the bottom to divide it by. $910 megaliters. And you don't want to put a decimal at the back because that would make it 3 sig figs and we only had 2. Now, if we did it the other way, let's see if it would also work the other way. Tetraliters is 12 minus megaliters is 6. That tells me I need to go 6 places. 1, 2, 3, 4, 5, and then we added on that 0. So we did go 6 places. So it works either way. So as you start working on these on practice, you can decide which one works better for you. I love dimensional analysis. I'm nerdy that way. You can do so many things with it, and we use it all the time. And a lot of kids don't like it, so this may work easier for you on that. Was anybody not able to get the 910? If you got some number with a real large exponent, then you may not have put the bottom in parentheses, and then that'll give the calculator, or like I said, they'll do it in a different order. All right, let's look at another one of those. And I think your way would have worked too, right?
The,
Did you say 10 to the 6th? Was that what you had asked me a minute ago?
oh yeah, I asked because they're both outside.
All right, 4,096 megabytes. And I want to figure out how many gigabytes. Something I would never be interested in my whole life. Just give me a computer. I will never know whether I'm getting ready to run out of bytes or not. So start with your given. Megabytes. I always start at the top. Like I said, there's always going to be a 1 under it. And then I like to give myself a beginning and my end. And my end is I'm going to need to get to gigabytes. I need it to be the last unit left. So it's going to be at the top closest to the equals. All right. So we're going to have the same thing. I don't know how many megabytes are in a gigabyte. That's not part of my conversions. So what are we going to have to do first? We're going to have to get it to just bytes first, right? Because that's what they have in common. If I have megabytes here, I have to have megabytes down there. The units are really important. And I know I always have some students that don't like to put units. Doesn't work for you. When you get up to AP chemistry, if you hang with me that long, you don't have to put units until you get your answer. And we want to go to bytes here. So my one going to be at the top or the bottom? Bottom, right, where the prefix is. And mega is 10 to the 6th. Do y'all think I have that one memorized? I don't. Follow my, I have the basic ones memorized. I would have to use a great man, King Henry myself. So same thing, I'm bytes here. I have to be bytes down there. So now is my one at the top or at the bottom? Top, because that's where my prefix is. And giga, which I also don't have memorized, is 10 to the 9th. So you're going to do 4.096 times 10 to the 6th and get yourself an answer, and then come back and divide it by 10 to the 9th. How many sig figs should my answer have? Heard it. Somebody was scared to say it. 4. Should my number be getting bigger or smaller? A little bit smaller, right? Because I'm moving that way. And that's kind of a good check you can always do. That way you can make sure you didn't put something in the calculator. If you're moving toward the small units, your number should be getting bigger. If you're moving toward the big units. All right, what did we get on this one? Anybody? Perfect. Gigabytes. So I'm a 4 sig figs. So once again, let's see if I did this my other way, which I have a feeling that's what most people like. Mega is 6 minus, thank you. It's going to give me my -3. And is that what we did? Because it was right here, right? 1, 2, 3. So they both work. So which way do y'all like better? The first one. All right. Now I'm going to show you one where you can't do it that way, because that system of messing with the exponents only works if you say metric and metric. If you'll pull out your handout you got today and go to the very last one, I think it's the very last problem. On this practice, the answers are in parentheses. So there's last one that says, get your math hat on. That's not a threat. All right, if you look here, I'm starting in kilometers with this metric and I'm going to feet, which is English. I can't just look at that little chart. That doesn't work. You're given a couple of conversion factors. 2.54 centimeters is equal to 1 inch and 12 inches is equal to 1 foot. I'm starting in metric. I need to go to English. Which one of those two conversion factors connects metric to English? The first one or the second one? First one, right? Because it has both metric and it has English in it. So I'm going to have to use that one some way. Another thing that makes this problem a little bit harder is it only has sig fig. To me, the fewer sig figs, the harder it is. So I'm starting with 20 kilometers and I eventually want to get to feet. This is a pretty long one. So I start. So if I'm kilometers here, I want to be kilometers down there. This is my crossover. So can I go from kilometers straight to centimeters? What do I need to go through first? Just plain meters, right? 1 kilometer is 10 to the third meters. Now, here's meters. I need to be meters down here. Can I get from meters to centimeters? That we can do, right? Centimeters, the 1 goes with the prefix, the 10 to the minus 2. Centimeters here. I've got to be centimeters down here. Remember, we want to get to the English system. So now is when I can use this. Write it just like it says. The 2.54 stays with the centimeter. The 1 stays with the inch. That rule that the 1 stays with the prefix is just if you're metric. Once I become metric English, that rule goes by the wayside. Then I have inch here, so I have to have inch down here. How many inches in a foot? 12 inches in 1 foot. If we did it right, all of my units should cancel as I go from top to bottom. I'm left with just foot, which is what I wanted. So now put this in your calculator. You should do 20 times 10.3. And I think that's all that you need at the top. And then divide by, I don't know if you want to divide by each one separately or put them in parentheses and multiply them. Y'all are usually better at the calculator. See if you can't get that answer right there. Sorry. Did anybody get that number in their calculator? I mean, did anybody get that number for the answer? Y'all still doing okay? Looks very different from this, right? But the problem, and like I said, to me, this is hard, is I only can have 1 sig fig. That is my 1 sig fig. Since there's a 5 behind it, I have to bring it up to a 7. I can't just go from 65,000 and something to 7. So what do I need to do? Yeah, remember you have to do placeholders. So that's where you came up with your 70,000 and the answer's just written in scientific notation. But sometimes those are the hardest ones, to me at least. So please work on some of your practice. We will continue with this tomorrow on a gizmo. 403. It's almost like I planned it, which I didn't. And this will be some of the things you'll see on the quiz on Monday. Tutorials this afternoon if you need to. People that have been absent, y'all, if y'all are missing quizzes and a test, y'all need to come in for a quiz either this afternoon or tomorrow morning. Tomorrow? No, ma'am. I'll be here by 7. I don't come in quite that early. I was here, I was here at 6 a.m. today. On Fridays, I don't come in that early. Y'all have a nice day. I hope this recorded. No, what I was gonna say, when you, I think you said 10 to the 6 because you were subtracting those two, and that does work. But not all the students have memberships, so sometimes I have to teach it. Does that make sense?
Sort of.
But yes, yours, I think you would, because you could see that. Righty, where to now? See up there. Uh-huh.
Well, we have to do the, way to be.
No, I'm gonna leave it up to y'all. I mean, with that being said, I may throw in the bonus problem that, that may be kind of like that one I showed y'all at the end, Michael, and Michael. So then that way you have to do it in the analysis. Michael, we're gonna need to record. It's good,